Hey guys, this is Adhertan, and tonight I am going to publicly humiliate myself and my programming skills in the game called Shenzhen. So then this is something completely different from your from the Long Dark that we play on this channel too. Shenzhen is about building electronic devices and programming them. Now, I am a software engineer in my day job, so I thought like, hey, it would be cool to relax after all this programming I do at work all day and maybe do some more programming, I guess. Well, in any case, this is what we are going to play now. So I guess let's get into it. So this is the welcome screen. We have settings, we have data sheets. This game actually, oh, I should mention that this game is in early access on Steam. I will put a link to the game in the description. And this game also comes with a PDF file which has all kinds of like instructions and manuals for the individual electronic devices. It also has like the documentation of it also have a documentation of the assembly language that we will be using and some other documents that we will need. You can either print it. I have it written next to me on a tablet, so I can search to it. Although I already played a few missions just to get familiar with the game, so I hopefully won't need that too much. And hopefully what I'm doing on the screen will make sense to you. I'll try to actually explain what I'm doing, how am I thinking, and yeah, we'll see how it goes. So this is our main screen. We just moved into China, into Shenzhen, where we are starting to work for a company. Let's start a mail. Welcome from leader. Dear new employee, thank you for joining Shenzhen Long-term Electronics Company. We aim to become a world-leading company in the electronics industry and respected brand with products in homes, offices and public spaces across the world. Longtech Electronics was founded on the following principles. First, diligence. Second, connections. Third, salubriousness, whatever it means. Please keep these principles in mind as you contribute to our efforts. Wang Yonghong, CEO. From Carl Desky. Fresh meat. Just kidding. Welcome to the southern China. It's alright, I suppose. Except for the heat, smog, and lack of decent cheese here in Shenzhen. Still, far better than any engineering gig I can find back home in the UK though. I'm assuming you ended up here for similar reasons. Carl. From Joe. So I heard your newest ace engineer was going to kick ass and take names. Am I right? You've probably heard all about me already, but I'm a product guy who loves to find amazing opportunities and make deals happen. Let's do this. Joey Hayato, product manager from Wu Lily. Greetings and welcome to the team. As you've already been made aware, we are on a major international expansion effort and we are very eager to see you bring your skills and expertise to our company. Lily Wu, Vice President of Product, long-time contract. David something P someone. Something. My name is David, or whatever, in Chinese, and I was brought on to help Longtang with its international push, though I've only recently moved here from San Francisco, where I should point out, there is a very bright Chinatown. I'm really loving it far. It is truly fascinating to see a culture at once so ancient and so modern from up close. I'm sure we will be walking closer to get great successful products. Blah 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 blah. David blah blah peace on international product manager. From GG. Hello, my name is Ji Cheng. I'm the chief staff engineer. Your boss. I would assume you already know who your boss is when you start working in a company. Well, anyway, I have managed many foreign workers before, so please understand if I make mistakes here or there. Anyhow, I will send you your first job shortly. Important, read the manual. Yeah, that's the PDF. I already, well, at least skimmed through it. And now the game crashed. Fuck. So the game crashed on me, but we are back. Security camera, fake. Product, fake surveillance camera. Wait, am I recording? Bam. Security camera fake. This product is an imitation mark security camera. It has two blinking lights. The first light blinks in a regular pattern. The second light is an internet light, so it should be blinking in a more random pattern to resemble data upload. As you will notice, the design is partially complete already. A previous engineer quit before finishing the assignment. Note the timing diagrams in the verification tab. When you simulate, your output should match those expected values as indicated. Let the simulation run until it has passed all of the test cases to make sure you have a proper solution. G. Carl, I'm absolutely certain you do better than the last person. Objective creative working design. Okay, let's get to it. Public design. So this is our design. This is the board already is there. This is the board we are going to work on. This is the description of all the input and output. So we have active and network, our simple output connected to LED. So these are our outputs. Control the active and network output with fixed repeating signals as indicated in the verification tab. This is the verification tab, which indicates the expected output signals. So this is basically, these are analog, so we only have like 0 and 100 or 0 and 1. So the active one, that's this one, basically just goes 1, 2, 3, 4, 5, 6, let's say seconds off, then it's 1, 2, 3, 4, 5, it's 6 seconds on, then 6 seconds off, 6 seconds on, 6 seconds off, and so on and so on. This one is more random, so it's like 4 seconds off, then 2 seconds on, 1 second off, 1 second on, and then it repeats. So we already have the active one programmed, so using the MC4000 controller, so that's what I'm going to do as well. Use it, connect to the network, and now we need to actually write code that implement this. Now, so what we are going to do is, here we have a couple of lines where we can write, like this controller can take up to 8 instructions, so we can write 8 assembly instructions that the controller will execute in an endless loop and generate, and we will then generate this pattern. So what I'm going to do is, at the beginning I'm going to move 0, which means turn off, to the P0 output, and then I'm going to sleep for 4 seconds, or 4 cycles, or whatever that is. I'll just say seconds to make it simple. Then we move 100 to P0 to turn it on, and we sleep for 2 seconds. Then we move 0 again to P0 to turn it off and sleep for 1 second. Then we turn it on again for 1 second, and then we are basically done. You don't need to do anything else, because then it will loop again and turn it off. And this is basically, so we turn it off, wait for 4 seconds, turn it on, wait for 2 seconds, turn it off, wait for 1 second, turn it on again, wait for 1 second, and then the loop repeats, and it will turn it off again. That's good. The code loop, you can actually simulate this now, just going step by step, and you can see that this is doing exactly what we want. So we can simulate it all, and we can see the camera blinking. I will speed up the remaining tests, so we don't have to actually wait for it. And yeah, we succeeded. The production cost, there's only really one price that you can do it with. Power usage is 60. Lines of code, we have 10. We can go back. In theory, we could optimize this. This could actually be reduced, I believe. What we could do actually, this one we could optimize, because this turns it off, sleep for 6 seconds, and turns on, sleeps for 6 seconds. We could reduce this code to actually reduce it by 1 line, I believe. Actually, no, we don't even need to. We just by 1 line. Negate the accumulator. That's just a registry, basically a piece of memory where we can store a number. So what we can do is we would sleep for 6 seconds, then negate the ACC, and then move the value of ACC into the output. So we can actually save 1 line of code, and it will still work. Yeah, it still works. We saved 1 line of code. So when the simulation is finished, we moved a little up. So we now used 11 lines of code, previously 12, and we actually used more energy than before, which is interesting. Apparently, there is a price for each instruction, and I guess some of these instructions are more expensive. Maybe they're not the mathematical operation, and possibly the registry access is much more expensive than in terms of energy than just basically writing cost and that's from engineering point of view. Well, let's return to the email. Thanks for your prompt work on the blinker lights. Looks okay. G. Shenzhen days. Why are we even here? From Tilly88. Hi everyone, we have a bunch of new signups this week, so let me introduce myself. I'm your host, Tilly Liu, and I run this fun little mailing list for expats in Shenzhen. I'm a domestic pilot of MySpace for life and culture here, and with the help of color commentary. Yada 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 yada. I don't think I'm going to read all of this. There is probably some backstory to this game. I'm not sure exactly how it is, but yeah. So if you want to, you can just pause the game and read it for yourself. Moving on, replacement factory module. Our factory floor has some examples of all the equipment there that require control signals to be amplified. We had a device to adjust signals for this type of machine, but recently it was broken, smashed. Does that have anything to do with the guy who quit in the previous task? This is an appropriate project to teach you about inputs. G. Smashed? Hang on a sec. What happened? Is everyone okay? No need to worry. G. Okay, let's open a new design board. So we now have control in is a simple input connected to factory equipment, and we have control out, which is a simple output connected to other factory equipment, and the signal from control in should be multiplied by 2 and copy to control out. So if you open the verification, you can see that the output is basically twice as the values are twice as larger than on the input. So we input to P0 and output to P1, and what we do is actually quite easy. We move the input from what we read from P0, we move it into the account registry. I think it's called account. I actually don't remember. Registries. Actually, I can just find documentation for this. Accumulator, right? Not account. Accumulator. Then I multiply the accumulator by 2, and then I move the value of the counter to P1 accumulator. Sorry, I keep forgetting it was to the P1 output. Then I sleep for 1 cycle before I read another input, so we can test it, and it seems to work. So let's run all the tests. I don't think this can be done any more efficient. So okay, yep, production cost perfect, power usage. I guess you can do this with if you come back later on when you have more equipment available. And lines of code 4. You can do it, I guess, with 3, but again, you probably need better hardware. Return to email. Looks good. Thank you. Take care. Yeah, I will. Please enjoy a game. My daughter is learning programming. She created a simple card game. Would anyone like to try it and give some feedback for her? I put a link on everyone's desktop. She's interested to become a game developer. Wow, Jay, that's both a lot more polished and far harder than I was expecting. Your daughter's managed to design quite a challenging patience game. Maybe there could be an undo function. She says she doesn't think it needs undoing because it's actually quite easy once you develop some skill. She really takes after you. Objective: win a game of solitaire. Right. It's here. Solitaire. I don't think I'm going to play the solitaire because I already played it once. You know what? Screw it. You can watch me fail playing. This is not solitaire. This is not the solitaire you know from your all the Windows desktop. This is actually some slightly modified version. The rules are described somewhere. Right here in instructions. Who would expect that, right? Rules to be described in instruction page. But it's not that. It's not as what? How would I say that? It's not as it simply doesn't play the same way you would play your regular solitaire from Windows. won! Yay! Okay, good. I've actually won. Let's continue. Back to your email. We enjoyed the game. Lots of Chinese stuff. All the parts. Now that you are up and running, I figure it's safe to let you use all the lovely parts we have available to us. Just be warned that none of them all are going to be useful for what you are doing immediately. On you go then, Carl. Pulse generator. In order to test some of our new manufacturing, I'm implementing the pulse generator with certain requirements. However, instead of buying one on the market price, I thought we could simply create our own. For this project, you will need to take use of conditional execution. Please continue your study of language reference. Yeah, sure. I will totally study language reference. I already did. Oh fuck, but my tablet, which with my language reference, is running out of battery. Well, I'll solve that somehow. So button is a simple input connected to a button. Pulse is a symbol output connected to an electrical device. When the button is pushed, generate pulses is indicated in the verification tab until the button is released. Right. So when the button is pushed, we might actually need the bigger one for this. The difference between the bigger controller and the smaller one is that this one has more inputs and more outputs, but we don't need those actually. It also has two registries instead of just one, and it can take more instructions. It can take, I guess, 12 or so instructions. So what I'm going to do is, well, we can certainly write the loop that does the pulse, and that one is super simple, and that's moth 100 P1, sleep for a second, move 0 to P1, sleep for a second. So this is the loop. We can call it blink, or we can call it a pulse. Well, we don't need to, right? And we want to execute this loop only as long as the button is pushed, which means we need to move the input to the accumulator and then test if the accumulator is equal to 100, and if it is, we do the pulse. So yeah, so the TQ is test if equal, and then the two arguments, it could be the two registries we use the value 100 and the registry, the accumulator, and then the pluses indicate all the code that should be enabled when the condition is true. So let's test this. I'm not sleeping. Right. Actually, this sleep should be unconditional. And here we go. And it seems to work. Let's simulate. Yep, that actually works. So our power use, we actually use the more expensive one. We can actually, we can get cheaper, and we use more lines of code than most, and we use more energy than most. That actually calls for optimization. So first, we can actually optimize by using this one. I know that was correct. That was correct. So P1 and P0. I think I can copy the code over. Yep. And then I can remove this part. I wonder if there is a difference in power consumption just by changing the devices. So yeah, we are on the production cost, we matched, but we can still do better. And how we can do better? Oh, we can save this morph, and we can actually compare the P0 to not to the accumulator, but to 100. I can compare the input. That saves us the usage of the accumulator and one more instruction. So now we should actually, now we match the best possible power, the smallest possible power consumption. We are actually using 142, which is actually even better than what we did before. And we have 5 instructions. Apparently you can do it with 3, 2 instructions. That's pretty good. But that's probably requires to use different hardware. So this is good enough. Yes, looks okay. Suitable for our purpose. G. Okay, so we actually managed to create a few electronics. I hope you enjoyed it a bit. If you did, please leave a like. And I hope to see you in the next episode. Bye bye.